Now the next subheading is factorization of polynomials. Before that, we can see what is the factor theorem. If p of x is a polynomial of degree n greater than or equal to 1, that means p of x is a polynomial with degree greater than or equal to 1, and a is any real number, then x minus a is a factor of p of x if p of a equals 0, and p of a equals 0 if x minus a is the factor of p of x. X minus a is a factor, then p of a equals 0. P of a equals 0, then x minus a is the factor. This is the factor theorem. P of x should not be a constant polynomial. Its degree should be greater than or equal to 1. Now its proof. By remainder theorem, p of x equal x minus a into q of x plus r of x becomes p of x equal x minus a into q of x plus p of a. By the remainder theorem, remainder will be p of a when we divide p of x by x minus a. So here we can rewrite r of x as p of a. If p of a equals 0, then p of x equal x minus a into q of x, because here not p of a because it is 0. Okay, so here only x minus a into q of x, which shows that x minus a is the factor of p of x. X minus a into a number, that means it is a factor of p of x. Then next is, since x minus a is a factor of p of x, then p of x equal x minus a into g of x. G of x is the any for same polynomial g of x. That means p of x equal x minus a into any polynomial, because it is given that x minus a is the factor. So we can write p of x equal x minus a into g of x. For example, 3 is a factor. 3 is a factor of 6. Then 6 equal, how we can write 3 into 2. 3 is the factor into the number. Okay. So 3 is the factor of 6. Then we can write 6 equal 3 into 2. Same way, p of x equal x minus a into g of x. Any polynomial we can write here. Okay. Now, in this case, p of a equal what? A minus a into g of a. Substitute the value of x as a. Then a minus a is 0. So 0 into g of a is 0. So p of a equal what? 0. If x minus a is the factor, then p of a equal 0. Now NCERT exercise 2.4. Our exercise 2.4 first section. Determine which of the following polynomials has x plus 1 a factor. X plus 1 a factor, that means if p of negative 1 is 0, then we can say that x plus 1 is the factor of that polynomial. So here we need to check whether p of negative 1 is 0 or not. Here 4 questions are there. First question. X cube plus x square plus x plus 1. This is p of x. Then g of x we can take as x plus 1. G of x equal x plus 1. Now, if g of x equal x plus 1 is a factor of p of x, then p of negative 1 must be 0. Otherwise, what we can say, g of x is not a factor. So, here we need to find p of negative 1. In the place of x, we want to substitute negative 1 in the polynomial p of x. So, negative 1 cube plus negative 1 square plus negative 1 plus this one. Negative 1 cube is negative 1. Negative 1 square is positive 1. Negative 1 into positive 1 will be negative 1. Then the last one plus 1. Negative 1 plus 1 will be 0. 0 plus negative 1, negative 1. Negative 1 plus 1 will be 0. So, p of negative 1 equal 0. So, what we can say, here x plus 1 is a factor of the given polynomial p of x. Now, the next question. Here also we want to take g of x as x plus 1. P of x is x raised to 4 plus x cube plus x square plus x plus 1. x raised to 4 plus x cube plus x square plus x plus 1. Then here also we need to check what is p of negative 1. It is 0 or not. For that we can find p of negative 1. So negative 1 raised to 4 plus negative 1 raised to 3 plus negative 1 square plus negative 1, then last plus 1. Negative 1 raised to 4. Negative numbers even power will be positive. So 1, then plus negative 1 cube, negative 1. So this positive and negative into negative is negative. Then negative 1 square is positive 1. Positive into positive, positive itself. Then negative into positive, negative, then 1. Then the last plus 1. Now negative 1 and positive 1 will be cancelled. Sum of a number and its additive inverse will be 0. So this will be 0. The next 1 minus 1 also be 0. Then plus 1. So which is remain? 1 is remain. So here p of negative 1 is not equal 0. So what we can say? X plus 1 is not a factor. Here x plus 1 is not a factor for the second question. Now the third question. P of x equal x raised to 4 plus 3x cube plus 3x square plus x plus 1. So here also we need to find p of negative 1. So we substitute the value of x as negative 1. So negative 1 raised to 4 plus 3 into negative 1 raised to 3 plus 3 into negative 1 raised to 2 plus negative 1 plus 1. So negative 1 raised to 4 is positive 1. Negative 1 raised to 3 is negative 1. Negative 1 into plus 3, negative 3. Then negative 1 square is positive 1. 1 into 3, 3. Then positive into negative, negative 1. Then plus 1. So minus 3 and plus 3 we can cut because they are a number and its additive inverse. Their sum will be 0. Then the last negative 1 and positive 1 can be cut because they also like that. Then which is remain here? 1 is remain. So here p of negative 1 is 1. It is not equal 0. Then the next question, question number 4. Here 1 is not equal 0. That means what? X plus 1 is not the factor of given polynomial. Then the last question. P of x equal x cube minus x square minus 2 plus root 2x plus root 2. Here also we need to find p of negative 1. So what we will get? Negative 1 cube minus negative 1 square minus 2 plus root 2 into negative 1 plus root 2. Negative 1 cube is negative 1. Negative 1 square is positive 1. Positive 1 into negative, negative 1. Then minus 2 into negative 1 plus 2 minus root 2 into negative 1 minus root 2 into negative 1 positive root 2 then plus root 2. Then here negative 1 minus 1 is negative 2. Negative 2 plus 2 is 0. Then root 2 plus root 2 is 2 root 2. So what we will get? 2 root 2. So here also p of negative 1 is not equal 0. So x plus 1 is not the factor of p of x.